And there we go. All right, folks. Without a calculator. No calculator. Do the orange one. Without a calculator. Do the one on the left.
Wait, no, what are we supposed to be? You see that sign right there? I thought he said I don't know how to There is no spoon. Oh, they're right here. What'd you ask? Oh, no.
Okay. Hopefully you remember how to do longhand multiplication. We say 2 times 3 is 6. 2 times 2 is 4. And each time 2 times 1 is 2. I'm putting them in their place values. Because that's not really 2 times 1, that's 2 times 100 is 200. 2 by 3 is 6. 2 by 2 is 4. How do I go down to my next row? Why?
Because it's 30.
It's a placeholder because I'm not taking 3 times that stuff, I'm taking 30 times that stuff. Okay. And keep on going. 6, 3, 9, 6. And then what do? We add in their columns because their columns are like terms. So I'd have 6, 13, 9, 9, 13. Okay. Evil Mr. Burns is down there to remind you that you have been multiplying long chain polynomials since you learned how to do this in elementary school. See, when I say 3, what I mean is 3 times 10 to the 0. What's anything to the 0 power? 1. Isn't this in the 1's place value, which is 10 to the 0? This is in the 10's place value, which is 10 to the 1st. This is in the 100's place value, which is 10 to the 2nd, 10 to the 3rd, 10 to the 4th. So if I can multiply together things like this, because it keeps my place values lined up and organized, then I can also do it with x to the 4th, x to the 3rd squared. Okay. I can multiply together polynomials the same way. Because in place of the 10 to the 4th place value, I have the x to the 4th like term grouping. Now, what's that going to change about these? Okay. Literally the same thing. The difference is it's 6 and then 4x, 2x squared, 3x cubed, 4x to the 4th. when I take 3x times 3, it's 9x. X squared, x to the third, x to the fourth, x to the fifth. And you notice everything is nice and lined up. My like terms are lined up. This was just a method of organization for distributing, not multiplying by 32, but taking 30 plus 2 times 20,000 plus 3,000 plus 100 plus 20 plus 3. You are doing long chain distribution. Now, the difference is I don't know what x is, so I can't say 4x's plus 9x's. I can't say that's 3x's and an x squared because I don't know that x is worth that. So I just keep it as 13x. And then 8x squared, 9x cubed, 13x to the fourth, 6x to the fifth. Mr. Burns down there does his evil laugh because he says, if you can long multiply polynomials, the sad shake of the head, no, 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 you can long divide polynomials. So before I go long dividing, maybe we need to remember how do we long divide. All right, folks, let's go all the way back to elementary school. Find a corner, and I dare you to take long division, no calculator, go.
Oh my gosh. I'm pretty sure I have
Come on. Longhand division, just like you're back in elementary school.
I remember how it takes
You're starting at the wrong end.
Yeah, you start at 3. You start at 1. You put a 1 on top, and then you
carry the one.
What? You carry the 1 down.
Bro, can we just like 2 goes into 1? Can we just split it in half?
What did you learn in Algebra 2 today? Long division. Long division. There's a reason. There's a reason.
Okay, wait.
Yeah, you subtract 2. Okay.
I got that in my head now. How do you get it? Then you do 2 goes into 31.
I just like
I don't know how to do long division.
that is not right.
And y'all do it way different than we do. So it's really going to change what we're going to do today. If you, like, what you do is just a different organizational method. If you can do what we are about to do with the way you know, that's fine. Okay?
Who is it? My name's I actually can't hear. What do you mean? You should say you're not because they say one. Yes.
Okay. You take what is 3 divided by 2? 1. And change, right? 3 divided by 2 is 1 and change. Take the 1 times 2. Get 2. Then subtract them. You're saying that 3 divided by 2 is 1, whole group of 2, and there will be 1 left over, right? And then you drop it. It's a little warm. So that you have another multi-digit number, and you can do it again. You repeat. You start over. Now you say, what is 11 divided by 2? And change, right? I take the 5 times the 2 to get the 10, and I subtract to say it was 5 with 1 left over. And you drop it. It's a little warm. You go again. 12 divided by 2 is 6. 6 times 2 is 12. Subtract it. Drop the 5. Do it again. 5 divided by 2 is 2 and 1 left over. Drop the 6. And you keep going and going and going and going, right? Until you hit the end of the rainbow. If we could do this with multi-digit numbers that are arranged in descending order of place value, then I can also do it with polynomials. Okay? What? And then a 8, and then a 3, and then a remainder 1.
Remainder 1.
Which we don't actually call remainder 1. We're going to talk about that. Okay? 1/2. Ew. Okay. This needs to stop. If I have to split you up, I will. We're going to start with you write if you remember your vocabulary from way back when, you write to the dividend inside the dividing bracket, and you write your divisor outside of your bracket to say, I will be taking this thing divided by that thing. And it's done the same way. You look at the leading terms. You say, this guy divided by this guy. What is 4x squared divided by x? 4x, right? I would need to take x times a 4x to make 4x squared. So if that 4x squared divided by x is 4x, where should I be writing 4x? On top, above the x term, right? You always kept your place values lined up, so I will keep my variables and like terms lined up. Oh, we're getting there. We're getting there. Okay. So now, if I say that 4x squared divided by x was 4x, I now take 4x times my divisor. You will distribute. 4x times x is 4x squared plus 20x, a positive 20x. But then we always subtracted that thing, right? So subtract that thing. If I subtract this whole thing, are you cool with me just changing the signs like that? You're subtracting the thing. So change the signs. The 4x squared should go away. That was the whole point of doing this. Now I have 3x. I need another term, so I drop it because it's slightly warm. And then repeat it. Take 3x, divided by x. 3. I should put it above my constant because it's a constant. Now I will take 3 times this stuff, getting 3x and a positive 15. I took 3 times this stuff to get that stuff. If I'm about to subtract this thing, I can either just say subtract this thing, exactly like I have it written here, but experience has told me kids will get to that point and they will forget this. Like 1 time out of 8. They will forget that. That's why I always say just change the signs. If I subtract this whole thing, I change the signs. This particular problem, yes. We are not there yet. We have to learn this way because this way only works when I have a linear divisor. If I ever try to divide by a quadratic or higher, this don't work. The cool thing doesn't work. So, now, some of you on the last one, you went to old school 0.0, dropped the 0 and started going, right? That's how you were taught how to do it in elementary school. What if I said, what is 721 divided by 3? So 7 divided by 3 is 2. 2 times 1 is 6. Subtract 1, drop 2. 12 divided by 3 is 4. 4 times 3 is 12. Subtract. Getting 0. Drop the 1. 1 divided by 3. Uh-oh, it doesn't work. Stop. What's 24 times 3? 720. Isn't 721 over 3 24 whole groups of 3? Wait, isn't that a 0? Because it doesn't go in there? You can't just quit. Like 24 times 3 is not 720, right? You had to finish it off. You end up with this remainder. We don't say tack on as points, because how am I going to tack on a 0.0 here and keep going? Well, that would be in the tens place value. The 10th place value in terms of descending order is now x to the negative first. Now you're trying to take 1 over x and divide it by things, and it gets kind of gross. We don't want to say R1 because that's like kindergarten stuff. Instead, isn't 721 over 3 equivalent to 240 and 1/3? You take the remainder and you put it over the divisor. So I do the same thing with polynomials. At the end of this, I'm going to say plus a negative 31 over x plus 5. Now you don't have to say plus a negative 31. In fact, that's considered slightly improper. I would just say 4x plus 3 minus 31 over x plus 5.
X plus 5 would stay the same with the negative?
Yes. Just like over here, if I'm dividing by 3, I will have a third, some many thirds left over. If I'm dividing by x plus 5, I will have so many x plus 5s left over. Okay? I'm going to show it again. We can't just do one and done. Okay. I'll do this one again. Stage 1, write it out inside the dividing bracket. Goes 3x squared minus 29x plus 56. What is 3x squared divided by x? Write it above your x term. Multiply it times this whole thing. Getting 3x squared and a negative 21x. If I'm going to subtract that thing, then I'll just change my signs. Getting a negative 8x, drop it, a little warm, and repeat the process. What's a negative 8x divided by x? Negative 8. Take a negative 8 times your divisor to get negative 8x and a positive 56. My negative 8 just disappeared. Huh. And then when I subtract that thing, I change my signs with nothing left over. What does that mean?
That means you are done.
It's just that. I understand 3x minus 8 is my answer, yes. What does it mean when I divide and there's no remainder?
It's a line. Linear.
Goes in evenly. What's more vocabulary?
I mean, P.
51 divided by 3 is 17. Therefore, I can say that 3 is a
Multiple.
factor. Multiple is getting bigger. Factor is part of. Okay? 3 is a factor of 51. 17 is a factor of 51. So that means this polynomial factors into this evenly without anything left over.
Oh, this is like complete with squares.
Okay? These things are all related. Now we're starting with quadratics. because we know quadratics, but they get bigger. So, if I just gave this to you on your own and said, tell me what that means. No, stop and read it. Stop and really read it. Think about what the letter in front of x, the name of each of these functions, could represent. Okay. The answer to a division problem is called a quotient. Whatever I got left over at the end was called a remainder. This is the correct, appropriate notation to say, if I take a polynomial and divide it by a divisor, I will get a quotient. The quotient might have a remainder. If I have the remainder, I will write it as remainder over divisor. If I don't have a remainder, or if r of x equals 0, then that means d of x must have been a factor of p of x. The divisor must have been a factor of my polynomial, because I had no remainder. I had nothing left over at the end. Okay, I know it looks a little complicated, but the more you know about math, you start realizing, oh, this is just a sentence, but they wrote it in mathese. So, checking factors. This is why there is another way to do this, and I will show you, hopefully today. But it only works for linear factors. We have to know how to do this because if it's not a linear factor, maybe you are dividing by a quotient or a quadratic. Okay, now I have to do it by long division. Is that a factor? If it's a factor, what should I get at the end?
0.
Okay, so set it up. 3x to the fourth minus 4x to the third plus 12x squared plus 5, oof, divided by x squared plus 1. So, 3x to the fourth, always leading terms, divided by x squared is, I heard it, 3x squared. And I put it over here because I want to keep my terms lined up. Then, 3x squared times that stuff. 3x to the fourth and a 3x squared. So where do I write it? Right? I subtract this thing, so I will change my signs. Getting something a little different here. A negative 4x to the third, a 9x squared, and I will drop it, a little warm, and a 5. Now, because I'm going to hear the complaints after this, I will not continue from this point forward without telling you there is something horribly wrong with this problem right now. Who's got a job? A couple of you? Okay. Would you mind me asking, every 2 weeks or so, what's your paycheck? Around like 600. So let's say, working hard for the money over there, right? Now let's say Ali-san is expecting a paycheck of 608. What happens when you open up that little envelope and you see that?
They missed a 0.
Okay.
No.
Why is that 0 important in your paycheck?
More money.
Placeholder, right? It shoves that 6 from the tens value over to the hundreds value. It is important. What was missing up here and here?
Same value.
There wasn't an x term in either one of them. So I need a 0 as a placeholder. Okay. Now, I don't need to erase anything. Nothing has changed. Well, I need to erase one thing, just this. Because I need to put a 0x and then a 5. Now, I'm going to show you back here, it wasn't actually necessary in my divisor. Because if I had x squared plus 0x plus 1, wouldn't that have just tossed a 0x to the third right there? Okay, so it's necessary in my dividend, not in my divisor. The thing you're dividing into has to have the full form. The thing you're dividing by doesn't have to because it'll just be blank spots. And we know those blank spots are zeros. So I'll leave it up to you whether you want to put that one there. It is not necessary. Okay. So what I'm actually dropping here is a 0x. It's important because it shows me that I have to keep going past this step. There's going to be 3 steps. All right. Now continue. What is negative 4x cubed divided by x squared? Remember, it had to get shoved over. We needed that placeholder. So I'm not actually dropping 5 now because it's supposed to be over there. Right? I needed that 0 as a placeholder. Otherwise, I'm going to be missing part of my problem. All right. Negative 4x cubed divided by x squared is a negative 4x. We probably would have run into this trying to go to the next step anyway, because I would have said negative 4x, and it would have been above a 5 instead of a 0x. It would have been in the wrong spot. Okay? It would have been like you put your shoes on, and you're like, wow, that feels weird, and you look down, and wow, I'm tired. Wrong foot. Okay? Like, my kid will just giggle about it and say, hey, they're on the wrong foot. And just take off running. Okay. YOLO, dude. Negative 4x times the stuff. Negative 4x times x squared is negative 4x cubed. Negative 4x times 1 is negative 4x. I want to keep everything lined up. If I am subtracting this line, just change your signs. Now, do you see how if I had that 0x here, there just would have been a 0x there? Okay, so as long as you keep things lined up, that's taken care of, and you don't need it. So cancels, 9x squared.
Would that be a 0x squared below 9x squared?
Oh, yeah, it would. And drop it because it's a little warm. Shouldn't have written it. And then, finally, 9x squared divided by x squared is... See, this just, it didn't have enough room. It didn't have enough space. It looked weird. So I'll take 9x squared divided by x squared, getting plus 9. 9 times the stuff is 9x squared and a positive 9. I subtract that line. So, and what's left is a 4x minus 4. Now I know I'm done because if I try to take 4x divided by x squared, 4x over x squared is 4 over x. I now have an x on a denominator. I didn't want an x on a denominator. So I bring that up top as my remainder. We say plus 4x minus 4 over x squared plus 1. That whole thing becomes my remainder. Yeah?
If it's 5 minus negative 9, wouldn't that be 14?
But it wasn't minus a negative 9, it was a positive 9.
Oh, I see.
No, ask the questions. I want you to ask the questions. Okay? I'll put Dawson's up there before I forget. Oops. So, the big neon holy crap flashing sign letters at the top of the page, you need placeholders. You have to check for placeholders before you even write the problem. Because if you miss that placeholder, you will screw up. Case in point, we reviewed this, and then we reviewed polynomials, and we did long chain polynomials up to hexix, degree 6, by factoring in pre-calc. And I showed them how to do this with factoring. I also showed them how to do it synthetic division. One of their quiz problems, do it 2 different ways. You know how many of them did it perfectly by factoring, but by synthetic division, they forgot their 0. Womp, womp, womp. And they were wondering why they had such different answers. Okay? You need the 0 as a placeholder, or else you're gonna get hosed. So, speaking of zeros as placeholders,
Plenty of them.
Oh boy. Whoa.
Plenty of them.
now let's say, for example, just throwing it out there, if you were supposed to be getting that as your salary, but someone gave you that. A, you would be a teacher paying for family insurance. B, you would be very mad. C, you would be bitter about it and talk about it in your Algebra 2 class. So make sure you put your zeros in there as placeholders and have at it. Y'all, healthcare in this country is trash. I get $1,500 a month taken out of my check to make sure that we don't die in the hospital and then get $1 million bill.
So you do x to the 5th divided by x. Plus 0. Wait, I forgot like
Minus
6 places.
Oh, yeah, you have to do it.
Yeah,
You can do minus.
that's what's actually supposed to be a reasonable wage.
I was making it.
Yeah.
So I went from 11 to
Oh, 0x minus 4.
okay.
Okay.
So
Divide.
Oh, minus 32.
Yeah.
So break down to 0. Okay. Thanks.
Alright.
This can't multiply it by infinity. Should be a 0, right?
Yeah, but okay.
Bro, this is kind of easy.
Yeah, it's really
No, it's not. No.
It is
Easy, but
it's a repetitious pattern. It is algorithmic in the way that we do it, but there's a lot of moving parts. It's so easy to miss a negative and just screw the whole thing up. Hi.
x to the fifth by x. Would it be x to the fourth or 1 to the fourth?
1x to the fourth.
Yeah.
Right?
Yeah. All right.
Hmm?
How do I get? So x to the 5th divided by x.
Oh my
that.
Now x to the fourth times
X
x.
to the fourth and multiply that
X
by
to the
that.
fourth times x is x to the fifth.
So I subtract here.
Not yet, just write x to the fifth. X to the fourth times negative 2.
So it becomes x to the fifth.
Negative 2x to the 4th.
X to the fifth minus 2, is that what it is?
Now change your signs, because you're subtracting the whole thing. No, this becomes a negative.
2x to the fourth.
There you go.
Okay. Maybe that'll give me a little bit of that.
Multiply it by 0. Multiply it by 1. I know.
X to the fifth divided by x.
X to the 4th.
I've done that so far. I'm good.
X to the fourth times that stuff. X to the fourth times x.
X to the 5th.
X to the fourth times negative 2.
So it'll be negative 2x to the 4th.
Then you're subtracting this, so change your signs.
2x to the 4th.
That's what makes this go away. Repeat. 2x to the fourth divided by x.
So that would be 2x to the 3rd.
And it's a positive 2, so plus 2x to the third. Take that times the stuff. Oh wait, we forgot to drop it. A little hot. There you go. So.
Yeah, then it would be 2x to the 4th. And then 4x to the 3rd.
What sign?
Negative.
Yep. Minus 4x to the 3rd. And then you switch your signs.
So then those would cancel out, so it'd just be 4x to the 3rd. Drop it.
Keep going.
Then you multiply it by. Okay.
Okay. Is there?
I just need a little help. I get myself going, but
Okay.
I'm confused on right here because I already flipped. I should make that a positive.
No, you don't change signs until you're all squared away.
Oh no,
Okay.
no, this was that.
X to the fourth times x.
Is
X to the fifth. X to the fourth times negative 2.
Is
Negative 2 x to the fourth.
okay, but then I'd be flipping.
Now change your signs.
Alright, so then I end up with
Did you bring all that down again?
3x, right?
Dude.
Oh, done? Alright,
Right?
so 2
Placeholders. There you go.
to the 4th plus
The 0.
x to
Yeah.
The 0.
Excuse me.
the 0.
Yeah, you get
There you go. That's important, or else it's going to just on the whole thing. You got to have the zeros because you're saying, look, I need this space, but I got to remember there's nothing in that space. Okay? And then start over. 2x to the fourth divided by x.
Is I want to say 2x to
I mean,
the
2 to the third.
2x to the 3rd.
Yeah.
And you put that on top right here, but the third?
We always keep them lined up, right?
Multiply that by the.
Because that way we know when we're done because we'll hit the end of the rainbow.
Mm-hmm.
We'll hit the end, like literally run off the cliff. Okay? And then take 2x to the third times the stuff.
That would be. This would be 2x to the 4th.
Okay, 2x to the fourth.
How do you get 2x to the third?
Times negative 2.
0x divided by
That would
4.
be
Or no, 0x to the fourth divided
negative
by
2,
I did not understand a lot
negative
of
2x to the third,
So
right?
negative 2x to the fourth.
Negative 2 times 2.
Negative 4x.
There you go. Negative 4x to the third.
I think I did too, but only because we
Okay.
did the review.
And then change your signs. Good job. Shoop.
I just like to get rid of that, and I don't need that. So then this one
Plugged
is,
into
I can just say 4x to the third plus 0x.
There you go. Now we're remembering the 0. Okay. Do it again. Take x, sorry, 4x to the third divided by. Yep.
And then all this is 4x to the third, because
And then,
this one
yep.
would be, because I'm gonna add it, but it's negative 8.
Yes. Always write that before changing the signs.
Yes.
Don't change it on the fly, because then you change it on the fly and then you remember you're supposed to change it and then you change it back to what it wasn't supposed to be. That is what I do with the IE and C rule. I remember that I after E except before C, and then something with the we, and then I remember that I remember it wrong. So I remember that I remember it wrong, so I do it wrong knowing that it'll be right, but because I remembered that I remember it wrong, I'm actually right when I do it wrong, and then
So does this 8? So this 8 when I do, because it goes in like a pattern. This will turn into 16 in the next one.
Yes, but
And then it goes
finish.
into 32.
Yes,
Yeah,
that's how it's going to disappear. Here we go. Minus. Do this. Just. What is x to the fifth divided by x? X to the fourth times the stuff. X to the fifth and a negative 2x to the fourth. But then I change my signs, getting 2x to the fourth, drop it, little hot. Do it again. 2x to the fourth divided by x is 2x to the third. 2x to the third times x, 2x to the fourth. 2x to the third times negative 2 is negative 4x to the third. Change your signs. Drop it, a little warm. Go again. 4x to the third divided by x is 4x squared. 4x squared times the stuff. It's 4x to the third minus 8x squared. Change your signs. 8x squared. Divide, do it again. 8x squared divided by x is 8x. 8x times the stuff, that's too dark. Start over. Eight x times the stuff is 8x squared minus 16x. Change your signs. 16x minus 32. And one last time, 16x divided by x is 16. Change your signs. Woo! Who do what? Oh, does it say write it as factors? And then write it as a product of two factors. So I will now say that P of x is this times x minus 2. Okay?
Does it matter which order you put those in?
No. A times B is B times A. Okay? Now, that's long. We have to know how to do long division because we have to divide by things that aren't linear all the time. Not as much in here, but definitely when you get to pre-calc, you're going to have to divide by quadratics or cubics or quartics to find remaining zeros. But right? Yeah. I would like you to do this one because it actually is fairly quick. It looks scary, it's not. Okay? Yeah.
Good job, Chad.
It looks scary, but it's not. Yes, you need placeholders. Yeah, you do. Yes, you can do it.
Wow. Oh, it just skips all the way down to there. So just X. Yeah. Right? Yeah, what?
Yeah. What I'm saying.
So it'd be
Just X?
We do not use that language. If that's the language you're going to learn at school, you're not going to go back to Mr. Nels.
You do.
it just looks so good. Because you get X out of it.
Yeah.
X to the fifth.
Yeah.
It's X with all that gap in between. Okay. And then 5X to the fourth. Yeah, I know. That's what I'm saying. What?
Bro, what? There's nothing to minus 5.
There's 5X.
So 5x to the fourth minus 5?
Yeah.
Right?
Yeah. So the rest cancel out.
I'm not so confused.
It's actually easy.
Is
Oh, and then you just
X?
add it?
Is it just 5x to the fourth?
Actually, no. This is
So I got to here, but then I kind of just pieced it together in my mind that I can't go any more lower than this because X to the fourth.
But you don't split it like this.
Don't split it like
Yeah,
that.
and yeah, we don't split it like that. That's actually a thing called partial fractions if you try to split it up like that, a rational expression. And I know we do it in pre-calc. I don't know if we're going to get to it after this chapter. Like, it's not necessary, and it doesn't work that way. You put everything that... A, you do the problem. Don't try to BS it. Do the problem.
That's why I put that there.
Get all the way to the end and put the entire remainder over x to the fourth minus 1.
Yeah, you put the
So,
x.
once I
Okay,
multiply
well,
these
first of all,
back together,
this
does my
you
x to the
put in
fifth
wrong
come back?
place. It needs to
No.
be over here. And then
I'm pretty sure that 5x to the fourth divided by x to the fourth is not x.
yeah, but this is in the x.
So it needs to be 5x. Okay, yep.
No matter what.
Okay. What is x to the fifth divided by x to the fourth? Actually, x. Take x times the stuff. X to the fifth minus x. Womp. Change your signs. 5x to the fourth minus 5. Right? What is 5x to the fourth divided by x to the fourth? 5. 5 times the stuff. 5x to the fourth, negative 5. Change your signs. That's it. Which is why you want to do the whole problem. Okay. So it turns out that my polynomial is just that. That's it. So we have to know how to do this by long division because weird things are going to happen. And you need to write it all out to see what's going to happen when weird things happen. Okay?
Calculator, but
Show me thumbs. Long division. Okay? One more.
let me test it out.
One more. 6 points and no field goal. Sounds like our team. That is very true.
Very true.
Well, we don't have to add any zeros. Oh yeah, no place. If we needed them, I would have contributed.
8x cubed minus 4x.
And mine was. I said that. 2x squared. Yeah, see for this occasion, no placeholder, so.
Minus x squared? No.
Going down. And then you put 5x.
Yeah, which makes it easy.
Yeah. So then it's just gonna be 5x, right?
Yeah, plus 5x.
Wait,
Is
what?
it?
This is
Remainder.
hold on. I can't mental math right now. There is not a remainder.
In my books.
They're all using long division.
Oh, I forgot to flip the sign.
Since our divisibility rules of normal numbers, can we flip these and see if it's like backwards
Oh, that is
later?
Yeah. Okay. I did 2, 5, 2. It's -2, change signs, cool. So we've got 18, 9, 3, 18x.
That should be. It should be 18. I think I did the same mistake as you. I forgot that it was a square, and I didn't put the 2x square.
There you go.
I did the same.
It's 2x squared times 1, so 2x squared.
Oh,
There we go. Nice catch.
I did the same thing.
Nice. Is that actually beer pong?
No, it's cup pong. There ain't beer. Maybe you should be playing
Okay. What is 8x cubed divided by 4x? 2x squared. 2x squared times this stuff. Remember to distribute to both. 8x minus 2x squared, but then when we change the signs. No, that is something I want to make clear. Shut it. Write it as is, then change the signs. Because if you try to change the signs on the fly, I guarantee you're going to do it for some and not for others. You will screw up your signs and it'll just crap the whole thing out. Okay? Write it as is, then change the signs. 20. Okay. 20x squared divided by 4x is? 5x times the stuff is 20x squared and a negative 5x. Change your signs. Getting 12x. Drop it, a little warm. And say 12x divided by 4x is a plain old 3. 3 times the stuff is 12x minus 3. So when I change my signs, okay, I wanted to do this one particularly because A, we need a little bit more practice, a little bit. I saw some shakiness out there. 2, we're going to come back to this one because we need to look at how our next method is going to impact things. So, you notice the whole purpose of this is it's less about the numbers themselves, it's more about the multiplication and the organization, right? I want to keep all of my x to the fourths, and then my x to the thirds, and then my x squareds, and then my x's, and then my constants. And as I do that, don't all the variables just kind of take care of themselves? Like, the numbers are what I'm looking at. The variables are just there to tell me which column they go in. So, along comes famous dead dude, and he says, you know, can I just get rid of all the x stuff and just make this easier? And he starts trying things. And turns out, not only is it easier, it's about 1/5 of the time fast. But it only works if it's a linear divisor. Okay? Which, that's okay, because we spent so much time on quadratics, we spent so much time on factoring, aren't we always trying to get them into linear factors anyway? Like x plus 2 times x minus 1 times x plus 5. If I'm trying to get to linear factors, maybe I'll just use this system of organization for linear factors. And they do something called synthetic division. In synthetic division, I cut out all the fluff, all the BS. And I say, I'm not going to write all of my x's. Instead, I'm just going to write the coefficients. I am only going to write 1, -14, 51, and -54. Since this is synthetic division and I'm changing up how I do things, I'm also going to take that division sign, flop it around, leaving some room right below it to write a number. I'm going to flip it around. Like, huh? Okay, you notice how every time that we would multiply by the thing and then we'd subtract it. I'm subtracting it because I'm looking for the zero of the factor, which is always the opposite sign. So take the zero of this factor, -2, instead. And didn't we multiply and add, multiply and add, multiply and add? Well, I was actually multiplying and subtracting, right? But by using the zero of it, I have changed the sign at the front, which will change all the signs of my work. And then you multiply and add, and multiply and add, and multiply and add, and multiply and add. Check this out. You drop the first one, little worm, and then you multiply. What's -2 times 1?
-2.
Add them. What's a -2 times -16?
Negative.
32. Add them. What's a -2 times 83?
Negative 166.
Add them. Okay. You say, why? What do these numbers even get me? I took a cubic and divided it by x to the first. What should my answer be? Quadratic. So then I come along and I jam in 1x squared minus 16 x's. That's positive, so plus 83. So what's that number at the end? My remainder. Well, let's find out. We're going to back up a little bit, and I'm going to do synthetic on the ones that we've already done. I want you to look at how far into class we are. Yeah, and then you're going to hate me. Okay. What if I back up all the way back here? And I said 4, 23, negative 16. What's the 0 of x plus 5? Negative 5. Drop it, it's a little hot. What's a negative 5 times 4? 23 minus 20. Negative 5 times 3. Adam. I took a square divided by a linear, so I have a linear left.
Are you kidding? Should we do one without a remainder?
Uh-huh. What about this one? We said 3, negative 29, 56. What's the 0?
7. Boy, you are a mad genius.
Are you sure you didn't make this up? Create the...
No. But this only works when you're dividing by linear factors. About 5 years ago, I made kind of a bastardized hybrid between synthetic and long division for all long polynomials, and it works. And I started showing that to my pre-calc. I have never seen it in any book. It is literally just I came up with it and it turns out it works.
So you're going to be a famous dad dude someday?
No. Math wizard. No. Okay. Now, here's the deal. This one, look at it. Not a linear divisor. I can't do synthetic division with this. Because it says x squared. Remember this one and how long that took? 1, 0, 0, 0, 0, negative 32. Put the 0 of, and then multiply, add, multiply, add, multiply, add, multiply, add, multiply, add. And because I took x to the 5th divided by x to the 1st, I know that's 1x to the 4th, plus 2x to the 3rd, plus 4x to the 2nd, plus 8x, plus 16 with no remainder. It only works with linear. That's why we practice the long division. Because if you're dividing by something that is not a linear divisor, it won't work. Okay? That's like, I don't know, you seen a tamper before? A tamper, it's a big stick like a shovel, and at the bottom is just a giant metal plate. Thump, 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 because I'm tapping something down. Okay? That works extremely well when I want to tamp down this patch of dirt. Is that going to work really well when I want to put more sleeping bags in their cover? You know, y'all know that little bag that the sleeping bag goes in? All right, is that going to work? Just and it'll go in? No. It's not the right tool for the right job. Synthetic division works when dividing by linear factors. If I'm dividing by linear factors, I have this awesome tool. If it's not linear, then I've just got to stuff it in there the hard way. Okay? Then you'll like sit on it and get your knee on it and jam it in there some more. Okay? Now, I want to back up to... No, not yet. There. I want you to do that one by synthetic division.
Okay.
Okay, so now this is the actual got it for the synthetic division problem. So got it for number 3.
What's 50 times 7?
Oh my lord.
Oh, I forgot it. I just did a 0. Oh, placeholder.
Uh-huh. Who already missed their 0 as a placeholder?
Now me, I'm a beast. There we go. I got it now.
It still matters. 1, 0, negative 57, 56.
And 49.
What's that one? You want
That X squared.
Whoa.
Okay, so
8 times 6. So 7. So you got 1x squared. 1x squared plus 7x plus 8. Yes. Yeah.
oh yeah, and that's so much.
Yes, it is.
Way much.
And we have to know this because we're going to use synthetic division to start breaking down, say, a quintic, a degree 5, and finding all of its zeros. It's actually not hard if you have synthetic division. Because I take a quintic, synthetic divide, now it's a quartic. Synthetic divide, now it's a cubic. Synthetic divide, now it's a quadratic. Shove it in quadratic formula. Okay? It isn't hard, but we needed to learn this tool first. Okay? Are we okay with this? You write out the coefficients and constant with zeros as placeholders. You still need those. You write the 0 of this, and then multiply and add, multiply and add, multiply and add. Okay? Now I want to back up right before problem 3. We did this one, correct? We had 8x to the third, 18x squared plus 7x minus 3, 4x minus 1, 2, right? Right? Yeah. 2x squared.
She like tiny little. But he still What? No, actually, what you said. I will say you delivered
Okay, this is what we did before. Let's write this out. 8, 18, 7, negative 3. The zeros of my divisor. Set this equal to 0 and solve, and yes, it is 1/4. You say L. But you got to throw that little like 90s Valley Girl vibe on there. But it's actually not bad. Look at what happens. What is 1/4 of 8? 18 plus 2. What's a quarter of 20? What's 5 plus 7? A quarter of 12.
I equals 0.
Okay, it still works, but look at the numbers.
8, 20, and 12. Oh, yeah.
Why did I get different numbers this way?
You gotta divide, you gotta take that 1/4. Take it by 4.
Okay. When I turned this equal to 0 and said x is 1/4 to do this, I am no longer dividing by 4x minus 1. I was dividing by this. It's still the same 0, right? If I say x minus 1/4 or if I say 4x minus 1, they have the same 0. What changes is how the graph looks. It might have a 0 at 1/4, but one of them looks like this, and the other one looks like this. It is 1/4 as tall.
Neither of those are 1/4. What? Aren't they linear?
What? No, I get a quadratic left over.
Oh.
Okay? So, to take care of that, this is a big note, and this is not in our book. They just expect that you're gonna know this. If I'm ever dividing by something in the form of ax plus b, I also need to divide my answer by a. 2, 5, 3.
X squared. What? X.
Okay. Since I divided this by 4 to get this, I have to divide my answer by 4. And that is very tricky about synthetic division. Synthetic division itself is easy to perform. You just have to remember that if you ever divide to get the 0, you will have to divide your answer as well. Now, technically, what I'm supposed to be doing, and I know you don't want to, is if I divided by 4 to get this, I'm supposed to divide by 4 here as well. Like that. Technically, that's what I'm supposed to do. But whether I divide by 4 before multiplying or divide by 4 after multiplying, it's still times 1/4 and multiplication is commutative. So I'd rather do it at the end when I've got nicer numbers. So that is very sneaky. That is extremely sneaky. Those are all regular linear. I don't like that. So let's do the one right next to it. Let's do 7 by synthetic.
Oh boy. It did not matter.
Right next to the one I was just doing.
Number 6.
Just that number right there.
Oh, gosh, kid. It's 2, right? X equals 2.
No. X equals 1/2.
Okay, well, you know
I would just showed you this one by synthetic.
Gotcha.
That's that is a big flashing neon sign. Whoa.
Oh, 2.
Now, if you get a remainder, you don't divide the remainder. It already has the 6x minus 3 under it, if that happens.
we need to divide by 6. Oh, divide by 5. No,
Divide
you
by
need to
2
divide by
counts.
6 because you have to
Yeah.
divide by 6.
That's the second.
You divide by 2.
It's like
Oh.
divide by 4.
Right, you divide by 2. It's 3 over 6.
Dude,
Yeah.
we're back here.
Over 6.
Oh, I did that one.
Okay, well, I'll still check it. Positive 2. You
Positive
use
two.
the 0 of this.
Okay.
Okay?
So all I have to do is just mix around. Or just,
The 0 of it.
okay.
Would you divide by 2 or divide by 6?
2.
Yeah, dude.
Wait, I don't know. Would you?
You got to, because you got to reduce it.
It's a remainder.
If I divide by A, do I divide by 2 or do I divide by 6?
Divide by 6 because 6 is A.
Just because it reduces doesn't matter. You still divide by 6. Yes.
Well, you had 5, like, divide by 2.
You know, Callister.
You're saying 2.
No. No. 2x squared plus 4x. No. I need that. No, Dawson, no job. Dawson counts. Whatever it up. Man, so you said it was 2. Kaden, you were saying 6. Exactly.
Hey! Bell's about to ring. I want you looking up here. I did it by long division and synthetic. I want you to look at what should I be dividing by? By whatever the A is. Okay, so it becomes 2x plus 4. Notice, you don't divide your remainder. Your remainder is still your remainder. So minus 5 over 6x minus 3. Okay? Hi.